All right, so very glad to be here today. I was only minimally involved with AIRBODS as a member of the advisory panel. It's great work, and we've stolen Ben Jones and Chris Hidden to help out with a new ASHRAE infectious aerosol control standard that we've just started to develop. So having these connections has been very useful for me. I was asked to provide an international perspective. I'm not from the UK, so anything I say is an international perspective. I've not tried the 15 minutes that I had to give you some kind of a statistical overview of all of the world's air quality standards. These are really observations from 25 years or so of working in this area. When I first came to Loughborough in 2013, and I gave a talk on the need to improve indoor air quality and to harmonize it with energy use of buildings. And I'm still giving that talk several times a year. So this remains an important issue for us and for me. All right, so perspectives. Hazards are universal. I think this is the first thing we should say, is that the people are people, and air contaminants, if they're present, have fairly consistent effects on them. Things like indoor and outdoor source particulate matter, perhaps the most serious indoor air quality risk that we face. Ozone from outdoors is in high concentrations and in some areas, and being highly oxidative. It's bad for humans directly, and it also causes other kinds of indoor chemistry. In urban areas, outdoor emissions from fossil fuel combustion are important, whether that's transportation or power production. Indoors, we have sources from the building fabric. What do we make our buildings out of, and what kinds of things do they emit? So VOCs and SVOCs are important emissions from building materials, and processes are important as well. So if we still allow smoking in buildings, environmental tobacco smoke is important. If we use natural gas, methane exposure, nitrogen oxides, then there's the emissions from cooking very well. And of course, infectious aerosols, which I've been dealing with in a very intense way for about 3 years myself. And then we should also mention allergens and asthma triggers from things that we live with, like dust mites and mold in buildings, which is a problem here, the mycotoxins they produce. So hazards are universal, but risks are local. There's not one single global profile of exposure. We have to look at the environment and understand what's present, and then decide what to do about it. Outdoor air quality varies tremendously from one place to another. Heating and cooking practices, as we heard from Heather yesterday, contribute a lot to both indoor and outdoor pollution. How we build our buildings, what they're made out of, and how we condition them, the HVAC system type, if there is one. I often quote Paracelsus in my indoor air quality lectures, because it makes you sound smart if you quote people from the 16th century. He said, and I'm sure everyone knows that all things are poison. The dose that makes something a poison or not a poison. Kirk Smith very recently said, actually, that the place makes the poison, because where you are determines how exposed you are to things that are present. I think that's a very useful thing to think about when we discuss controls. I think one of our problems worldwide is the lack of a consensus on what acceptable indoor air quality should be. If you look at ventilation standards the world over, they're all fairly consistent in what they say as a minimum standard. And the main focus is on odor, perceived air quality, subjective impression of air quality. And to that we add typical exposures to contaminants that are present in buildings being below established exposure limits. So if there's a threshold limit value for something, that we're supposed to stay below that. Whether that's good or not, it's debatable, but it's an attempt to at least prevent high risk of developing diseases over a lifetime that are related to indoor exposures. So the statement that we use in ASHRAE's ventilation standard is no known contaminants at harmful concentrations is determined by cognizant authorities. So you have to know it's there, and there has to be an authority who's developed the limit, and we actually don't have limits for a lot of contaminants. And infection transmission is not addressed at all in those standards. And if you really dig into even healthcare standards and talk to the people who write them, they'll tell you that they don't know either, that most of the ventilation rates and the filtration requirements have been handed down from generation to generation because they seem to work. These are not true necessary criteria. And of course, everyone's familiar, I hope, with the curve on the left here that relates ventilation rates to subjective acceptability, which gets us our typical 7.5 liters per second per person in most environments. Our standards are generally prescriptive, not integrated, not based on performance and the overall effect. So we say you must have a certain amount of outdoor air that's clean enough. That's usually done on the basis of a per occupant amount and a per unit floor area amount, and a minimum filtration level. In some standards, it's not even required under all circumstances. ASHRAE standard 62.1 only requires filters if you have wetted cooling coils or other wetted airstream surfaces. Most people don't realize that. So why is that? It's because the filter is there to keep the coil from getting dirty. There is no filtration requirement for recirculated air in these standards that's to reduce the PM exposure of the occupants. So we have multiple controls, but they're not, we have no sense of what the cumulative effect is and how we're using those to target a specific type of contaminant, something we can work on. We'd like to define air quality in terms of a nice compact set of contaminants that we can measure and control. ASHRAE has been working on its indoor air quality procedure for years, and we've made a good improvement in that recently, in that we now have a specific list of contaminants with levels of concern that have to be met. But the problem is that there are 15 of them, and they're not present in all environments, and some of them are hard to measure. So this is still not a practical definition of indoor air quality. Another important thing that we need to recognize is that unlike outdoor air, indoor air is rarely regulated at all. In the United States, we have the Environmental Protection Agency, we have the Clean Air Act that has established the National Ambient Air Quality Standards. So outdoors, we've made great progress. Indoors, there's no regulation at all. If you look around the world, many countries have what are supposed to be indoor air quality standards, but when you look into those, you find out in a place like Singapore, that's often pointed to as a model, that when you ask the government, do we have indoor air quality regulations, they say, no, there are none. This is all voluntary, and we're publishing recommendations, and we know how far those get us in many situations. Monetizing the impact of indoor air quality is a problem. Monetizing in a certain way, in an actionable way for a particular owner. So there are plenty of studies that show us that there are effects and that they can be very significant in their costs if we look at that across, say, a whole country or across the world. The effect of 7 or 8 million excess deaths from air pollution, for example, or $350 billion a year in the United States from avoidable indoor environmental quality problems. But what we need to know is if I spend $100,000 more on my building, when am I going to get that money back, if ever? And that would really help us to promote this issue. So we have benefits that we know exist, but they're hard to quantify. We don't have standards that are based on economic analysis. Now, in energy, we've been doing that for a long time. The requirements in ASHRAE's energy standard, which is the code basis in the US, are based on life cycle cost of these things that people are required to do. We don't do that for air quality. And if we did, we would be doing a lot more. We also have a split incentive problem in terms of monetization. So the beneficiaries are not necessarily the ones who pay, which means that there's room here for regulations to help redistribute money. That should be something that governments are good at, is helping move money from one place to another to get something useful done. Of course, they may have to print it in the first place or take it from someone, but still we need a certain amount of regulation. Energy and carbon are monetized, and that has always given them more influence when we're looking for ways to spend resources than for air quality. Just to point to both this issue of monetization and differences regionally. This is a nice piece of work that was done by some Canadian researchers where they looked at the cost benefit in terms of reduced morbidity and mortality from having different levels of filtration using the ASHRAE MERV scale. And what we see is that as you go from 6 to 16, the lowest to the highest efficiency, you get greatly increasing benefits. And the worse the air quality is outdoors, the larger the benefit is. I think London is actually in here at the low end, $200 per person per year. That's not bad if you have better filtration in your buildings. So we need to look at things from this way. We haven't really done that at the level of standards and regulations. The best controls need to be tailored to local needs. Ventilation is not always the best. Ventilation with outdoor air, I think, is sometimes viewed as just a pure benefit, but it's bringing in maybe half or more of the particulate matter in the building. It's bringing in ozone. It's bringing in emissions from outdoor combustion. It adds to the energy cost, which creates more emissions. So it's not the unalloyed benefit that we sometimes think it is. And because many buildings are naturally ventilated, most buildings, the outdoor air supply is unreliable. So we need multimodal solutions that include air cleaners, but air cleaners are a swamp. There's a lot that we don't know, and they may be expensive to implement. These alternatives need to be studied more. That's one of the main things we're focusing on in our work in ASHRAE these days on standards. There are a lot of products that make claims that aren't backed up by good research. There are not standard test procedures, and there's little or no regulation, certification of products. So all of those things are things that we're working on. We also have the problem that in the construction industry, about the only thing that's regulated is the design of the building. Once the building is finished and occupied, then anything can happen. So ASHRAE standard 62.1 covers all of the things shown in this list. Is the outdoor air quality adequate? Requirements for systems and equipment design, the ventilation rate procedures that determine the quantities, construction and startup and operation and maintenance. The only thing that makes it into the building code are the prescriptive ventilation rates, and that's pretty typical worldwide again. And we know that O&M is really important. Even before COVID, the General Accountability Office in the US did a study of schools, and they found the #1 maintenance items was HVAC systems. 50% or 41% of school districts had 50% or more of their systems that were in need of repair or replacement. So this is a significant issue, as Malcolm was noting. And then the perceived conflict between energy/carbon, now we have to say that too, and indoor air quality is a barrier to progress. Every time you say we want to improve indoor air quality, you will immediately get the pushback that, well, isn't that going to increase energy use? And that's a problem. So we need to address these two things together, and that's really the topic of my talk this afternoon. What do we need? A lot of research, which exposures matter, more about dose response, standards that are performance-based, and supporting standards that allow us to rate things like the performance of air cleaners. In the policy arena, disclosure and enforcement, that's what you do after design. We need to start having testing of buildings and put air quality certificates on them, just as we are now accustomed to doing with energy. And social policy, carrots and sticks. What are we going to do to incentivize or require that the things that need to be done are done? And to wrap up, I think that the place we should start is with the precautionary principle. We should take reasonable measures to avoid threats that are serious and plausible. That means sometimes we have to act without perfect knowledge, but we know that the consequences of not acting are severe, as we found out during the pandemic. And that's all I have, so thank you very much.